Hi there, welcome back. This is the second video on the Korato tube preamp, the 10th anniversary reference preamp. If you saw the first one, you'll know that I did the schematic of the power supply and had a look at how that was built up. And now we've got the preamp itself. It's actually quite simple. Two controls on the front. We've got the selector with 5 inputs. They're all line level inputs. Then we've got the volume control over here, which it's a stepped attenuator. So it's not a pot. It's actually a switch with selection of resistors. We'll look at that in a minute. There's a LED in the front here, power on LED. So pretty neat all around. The back is similarly self-explanatory. If you recall, this is a full mono. It was 2 separate supplies to create a full mono system. So we have the power supply for the left over here through that umbilical cord. We've got the inputs over here and outputs. Now, as you can see, just the inputs over there, 5 inputs. This is tape in, there's a tape out, and then 2 main outs, left and right. And of course on that side we've got the connector for the power supply for the right channel. Now the inside is pretty interesting, and this is what I was really quite keen on. I wanted to see what circuit they'd used for these for the preamp active element itself. Now 2 sections again. The one board on the left is loose because I lifted it up to draw up the schematic. The one on the right is still in place. We'll look at that more closely in a second, but I just want to give you the overall view. Left channel, right channel, or vice versa. We've got the switching happens at the back here. You've got a 5-way 2-pole switch for the inputs, switching the respective inputs. There's your 5 inputs, 1, 2, 3, 4, 5. Strangely enough, the first one doesn't have a shielded cable going in. This shielding is done with the ground of the shield, or the shield itself, grounded only on the one side. Because if you follow to the other side, you'll see there's nothing there, which is the right way to do it, just to remove any noise being picked up on the wire itself. For some reason, channel 1 or input 1 doesn't have that. Don't know why. And this looks original. Doesn't look like someone's failed to put that in. Pretty good quality switch. Nothing special there. Very neat. And then the selected inputs go to the volume control, which in this case is a stepped attenuator. And as you might know, the result, or the way this works, is that it switches in resistors to give you different amplitude levels as opposed to potentiometer. Quite a lot of advantages to this kind of volume control. You can read about all that on the net. There's various types. There's the shunt, the series shunt. All of them have their own advantages and drawbacks. The main one here is that the left and right channel levels can be very, very accurately matched. So you don't have the problem with a stereo potentiometer where the tracking between one channel and the other might be different, resulting in different amplitudes coming out. So it looks pretty good. Looks like a pretty good quality switch over here. They've used metal film resistors throughout. A little bit of a problem with some of the soldering, but that seems to be a feature throughout. Soldering is not all the best. But anyway, I won't go into that. We've got the inputs coming in there, a common ground which is then connected to that plate at the bottom. So this is the first time that the left and right grounds meet together, and they are connected to the bottom plate. We've also got a copper strip over here connected to the bottom plate and to the top plate, so it touches the top plate here to act as a shield. And then we've got the channels. Now, as you can see, not much there. 2 tubes, a couple of resistors, and about 4 capacitors. And I did do the reverse engineering on that. I drew up the circuit, got some more components on the underside. I drew up the circuit, and this is a very interesting circuit actually. They use a Mew Stage preamp here, which is something I have not actually seen before. Read about it, but not seen before. And the way this works is you use the triode. That's a triode and that's a pentode. And the way Mew Stage works, which I'll describe when I look at the schematic, is that the triode acts as a voltage amplifier, and the pentode acts basically as a current amplifier or constant current source. What it's really doing is creating a very, very high resistance, plate resistance, to the triode, which makes the linearity of this optimized. And the result is actually pretty neat. So much so that for the first time ever, my wife walked in and asked what I'd done differently to the sound when I had this thing on test. She's pretty tone deaf, and this is the first time she's actually noticed anything different. So this is a first, and I have to look at this with a newfound respect, if for nothing else, that it actually attracted her attention. But yeah, I've got to put this thing back because, and this is the main thing, I have not found the problem with this so far. I have put it on tests and I cannot reproduce the noise for some reason. It could be all sorts of things. It could be a ground problem. It could be a problem with one of the valves on the preamp itself. It could be a problem with one of the valves on the power supply. But because I can't actually hear the problem or witness it, I don't know whether it's both channels or one channel. I wouldn't think it's both because these things are pretty well separated. There is one thing that I started wondering about, and that is that this thing is completely floating as regards the mains earth. There's no earthing on this. The common grounds over there are actually just the audio grounds, and they don't actually, well, they do meet the power ground, but there's no connection here to mains earth, and the power supplies are completely isolated from mains earth as well. So if you connect a source in here, CD player or something that doesn't have mains earth either, and connect this to a power amp that doesn't have mains earth either, you are possibly creating a situation where things could oscillate. That's a theory, it's not a fact. I'll have to look at that a bit further. Anyway, enough waffling for now. Let me show you the schematic that I drew up. And I must admit, it surprised me because it's not a new schematic. It's not a new circuit, but it's certainly the first time I've seen it implemented. And as I said, the result is bloody good. Well, here we go. Here's a schematic. I believe this is pretty accurate. There are a few things missing here. I'll point them out when I get to it. And it all starts with the input selector switch. It's a 2-pole 5-way. Each of the sides obviously takes one channel, left or right. You got your 5 inputs, CDs and tuner and auxiliary and tape in, and whatever gets selected goes out back through this 22K resistor to the tape out if you want to tape it. Whoever wants to do that these days, I'm not sure. But then it goes through a stepped attenuator, and that's the one I showed you just previously. I believe this one is a ladder version. There's quite a bit written up on stepped attenuators on the net. A lot of advantages to them. They're a lot more expensive than using a simple pot, but they do have a lot of advantages. The main one being that because you're depending on discrete resistors, which tend to hold their value very well and which you can match from one channel to the other very well, you get very, very good channel matching. So you don't have different levels on on left and right channel like you could possibly get with a normal potentiometer. Very difficult to match in those cases. You can also tailor the steps to however much or however little you want. You can make them, 3 dB steps, 1.5 dB steps, smaller steps at the beginning of the pot of the rotation and more at the top. It's really up to you, and there are all sorts of tools on the net. You can actually calculate the steps, the attenuator steps, the resistors for different attenuation steps, and so on. So it's pretty good thing to go look up. They do a very, very good job of describing how these things work. And also they describe the different types, the shunt, ladder, and series. This one I believe is a ladder. Now that then sees a 470k grid reference, ground reference resistor, and then it goes into a dual triode. It's one tube. It's one tube with two triodes, and the one they've got here is the 5687WB. All sorts of triodes would work here. This is the one they've used, and everything is calculated around the requirements of this particular one. The two triodes here are in parallel. I think the main reason is they had two tubes, or two triodes in one tube, and they were going to use one tube per channel, so you've got two triodes, use them. The way they are set up in parallel with separate grid resistors, grid stoppers, the 150 ohm, just makes them a lot more linear. They tend to balance each other out for any differences between the two triodes, although they would be pretty matched anyway, being in one envelope. But they work as one, so you can look at this as one triode. And all you've got here really is the start of a normal triode voltage amplifier. And that's really what the triode does in this particular circuit. I'll show you the rest in a minute. This thing is cathode biased with a 330 ohm resistor. It's got a cathode bypass capacitor of 100 microfarads, which the value of the cap really operates on just about all frequencies. So you are doubling the gain of the triode voltage amplifier stage, and it really doesn't have much of an effect on the frequency response because the capacitor is pretty high. If you wanted just to boost the upper frequencies, you'd make this resistor, this capacitor, a lot lower. You could make it, 1 microfarad, 0.1 microfarad, and it has a tendency to increase the higher frequencies. 100 microfarads, you'd have to do the maths, but it's probably coming down to below 20 hertz. So it's really acting as a doubler for the voltage stage gain. Now, what normally happens in a normal triode voltage stage is that from the anodes, from the top of the anodes, or one anode, you would see a anode resistor to the B+, to the supply, and then your signal will be taken off the anode. Now, what they've done here is they've got this whole contraption at the top with a pentode. And this might look fairly complex, and it is in fact, but all this is doing is acting as a sort of constant current source. And it's allowing the triode to see a very, very high resistance, an infinite resistance in fact, which is what an ideal current source has, infinite internal resistance. And the pentode does act like an active variable resistance. It gives it the right current, a fixed current, a constant current, and regardless of the load, that's what it's supposed to do. Obviously this is all in ideal conditions, but that's what it's supposed to do. And this particular implementation is called a Mew Stage. And the reason it's called a Mew Stage is because the pentode is acting as an active load to the triode. It allows the gain of the stage to be equal to the mu of the triode. And it doesn't require, as you would require if you wanted to get maximum gain, an infinite resistance to the B+, because it's an active resistance effectively. Now this particular circuit, exactly this circuit, is described in an article by a chap called Kimmel, and I'll link that because it describes the use of a pentode in the upper part of these cascaded systems, and it's very well described, a lot better than I could do. If you're interested, go and have a look at that. It's really nicely written up. And the way this works, it works very, very well because the result is amazing. It gives it a lot more clarity. There's no mudding, it's very linear. That's one of the main characteristics of it. It also has a very, very good power supply rejection capability. So effectively what's happening here is the pentode can forgive any fluctuations in the power supply pretty well, even though, as we've seen before, The power supply on this thing is way over designed and very, very well built. What happens here is you've got the Mew Stage, and then you've got your outputs and the coupling to the output. That 220 nanofarad capacitor is a very, very good quality capacitor. It's an audio note, 0.22 microfarads, and it's a copper foil, paper and oil. So one of those things that costs a fortune in itself. So the concept here was actually pretty good. Use a simple circuit and use very, very good components. It's a good recipe. No messing around and no cost saving. So yeah, it does the job. What we've got at the top here is the B plus coming in. That's the 221 volts we measured in the previous video. It's filtered with this 4.7 microfarad film cap as well. It's also a film cap. Just a slight filtering, and then it goes through a 1K resistor to provide the B plus. Basically, we don't need to have a highly regulated power supply because, as I said, this particular circuit is very forgiving of power supply fluctuations, but we've got everything in this soup. And the output then obviously is a direct output to the preamp out. There are two outputs, they're in parallel, so they're identical. This EF802, the heaters of this EF802 are actually the ones that are raised above zero, and as you can see, because the triode is creating a dividing effect on the B plus, and because you don't want the heaters of the EF802 to have great difference in voltage between themselves and the cathode, we've raised that. And if you recall, there were the 6 volt heaters coming out raised to about 71 volts, whatever it was. I think it was about 68 on one, 72 on the other. The important thing is the difference between the two, which is 6 volts, and that's the heater voltage for that triode. That's why that second heater voltage supply was created. It was to raise it above ground for the EF802. The 6 volts, the 6 volt one, the black thin wire had 6 volts reference to ground. That is used for the triode heater. And that's really it. There's not much else here. We've got everything fitting together very nicely and very simply. And as you can probably see, there is no actual connection to mains earth here. In fact, there's no connection to any supply except the ones that come in directly from the separate power supplies. The grounds themselves are all referenced to each other on both sides. This is the first point where the grounds meet each other. So left meets right through the ground. That's the first part of joining that happens here. Otherwise, they're absolutely independent supply channels, and they've gone to quite an extreme to achieve that. You could have done that with a lot more simply with one tube for the triode, sharing the two triode parts inside the one tube. You could have done it a lot more simply. They decided to go all out and do it right. Anyway, that is the schematic, and as for the problem with this preamp, I'm beginning to wonder whether it has a problem at all. I cannot, for the life of me, reproduce the fault. I just cannot. It's just working perfectly. So I really don't know what to tell you. And here's the final result. The preamp at the bottom, two supplies are at the top, and this is probably how you should not stack them. In fact, from the experience I had, you probably don't want to stack this at all because these supplies get really, really warm. I actually tested it with the supplies underneath and the preamp on top, and it actually warmed up a bit more than I liked. Anyway, the result is I've just put in a switch on there which connects the earth to the ground if you want to, and if you want you can just lift it, so it gives you the choice. That means now that the ground is actually connected to mains earth, and there you've lifted it. Now that gives you an option. If you do get some sort of oscillation, you've got a choice. I still think there's probably the only thing you need checking would be the voltage reference tubes. that might need looking into if the noise comes back, but quite honestly I couldn't get it. So hope you enjoyed that, hope you've learned something. I certainly have. Interesting implementation of the Mew Stage, and I'll be back with something new soon. Bye for now, thanks for watching.